Good morning, good afternoon, good evening, and welcome to SUSECon 2023. This is the Edge product roadmap. My name is Larry Morris, and I am the director over the product management team for the Edge business unit. And with me today,
Yeah, hey folks, it's a pleasure to be here and to welcome you all to SUSECon 2023. My name's Rhys Oxenham, and I manage the field product management and engineering teams within SUSE's Edge business unit.
thanks, Rhys. All right, so this morning, this afternoon, this evening, what we plan to do is we're going to give you an overview of the Edge product itself. I will begin, and I'm going to discuss the product that is actually available today, give you a little bit of background on why SUSE is doing an Edge product. We will then transition, and Rhys will walk you through the development work that we have coming up for our next release and give you a little bit of a glimpse into where we are going in the future with our Edge product. So with that, let's go ahead and begin the discussion about what you could actually deploy today with SUSE Edge. There's a little bit of a background to this. Edge devices are all about moving the physical compute environment outside the data center or outside a public cloud environment and putting it where the data is generated at the edge. Give you some examples. Point of sale terminals, an industrial controller, perhaps managing an oil or a gas well, a smart traffic management system, a hospital management or monitoring environment. These are just a few examples of what we mean when we talk about Edge. All of these examples are located in remote locations outside of a public data center or a public cloud environment. They're at the edge of the network. All right. Many types, in the examples I just gave you, of these edge environments have existed for some time. But now the compute costs have reached a point where companies are deciding to analyze, process, and utilize the data that's generated in these edge environments where it is created at the edge. So historically, the data generated, the information generated at the edge, when companies did something with it, they would move it to a centralized data center or a public cloud environment for that analysis. But this has several drawbacks. So let me just give you a few. First, there are privacy concerns. Businesses that move data across the wire risk that information being accessed unauthorized. And this is a risk both moving the data to and from that remote location. Second, there are infrastructure costs, either for that connectivity, for that infrastructure that connects the edge device with the private data center or the public cloud environment. And these costs, either it's a rental cost from a third party or a direct cost if you had to put the infrastructure in yourself. And third, there are bandwidth limitations. There's latency. When I move the data from the edge location to that centralized compute environment, then I analyze it, then I process it, I still have to move it back. And in both cases, there's a latency before the action can be taken where the data was actually created at the edge. So deploying compute where the data is generated resolves the latency problems. It solves the security, the privacy issues or concerns, and it reduces the infrastructure cost. This is edge computing. Computing that takes place outside a traditional data center, outside a centralized compute environment, or a public cloud environment. Back in October, SUSE introduced our SUSE Edge 2.0 release, the next iteration of our Edge capability. This is a purpose-built, it's fully integrated solution stack for managing the full life cycle of edge devices at scale. So the foundation for SUSE Edge is the Linux operating system specifically designed and built for edge deployments. This is SUSE Linux Enterprise Micro, and I'll talk about more of this in a minute. And on top of the purpose-built Linux operating system runs SUSE's industry-leading cloud-native edge functionality with either of our two Kubernetes distributions, RKE2 or K3S. And then the solution stack itself is orchestrated by SUSE's industry-leading Rancher Manager. Adding in Longhorn to provide persistent block storage for the Kubernetes environment, and SUSE's new Vector to the Edge solution stack provides a fully integrated solution with new Vector adding zero trust end-to-end security for your environment. So again, SUSE Edge, it's a purpose-built, fully integrated, complete edge solution stack. Let me go into a little bit more detail about SUSE Linux Enterprise Micro. This is an ultra reliable, lightweight operating system that again was purposely built for containerized workloads. It leverages and it's built directly based on SUSE's enterprise, hardened, secure SUSE Linux Enterprise operating system, and then merges this with more of a modern, immutable, developer-friendly operating system platform. The footprint of SUSE Linux Enterprise Micro has been reduced and optimized for these edge deployments, which are often smaller compute environments. SUSE Linux Enterprise Micro is immutable. What that means is that it's unmodifiable, and that directly minimizes the security threats. SUSE Linux Enterprise Micro can also be built and managed using Elemental. Elemental is a new SUSE open source project that was recently created and pushed upstream. Elemental provides full Linux operating system lifecycle management, and it's integrated into SUSE Rancher Manager as a plugin. So this provides edge customers with the ability to manage the operating system, the Kubernetes layer, and the application, all from a single pane of glass dashboard, SUSE Rancher Manager. Talk a little bit more about the Kubernetes layer itself. So SUSE has two industry-leading cloud-native edge functionality Kubernetes distributions, RKE2 and K3S. RKE2 is a fully featured CNCF or Cloud Native Computing Foundation certified Kubernetes distribution, and it supports the same APIs as upstream Kubernetes. RKE2 is also FIPS, or the Federal Information Processing Standard, enabled Kubernetes, which means it provides a compliance-based approach to security. K3S, on the other hand, was designed and optimized for smaller edge deployments. By eliminating unnecessary functionality, K3S is a much more lightweight Kubernetes distribution, has a very small binary size with very low compute resource requirements. K3S is also the most adopted, reduced footprint Kubernetes distribution in the world, with over 5 million downloads a month. Let's talk a little bit more about SUSE Rancher Manager. This is really the heart of the SUSE Edge stack. It is a multi-cluster management tool. It provides the user with zero-touch provisioning of this Kubernetes environment. And with the Elemental plugin, the full lifecycle management of SUSE Linux Enterprise Micro operating system is also possible. So for the Edge, SUSE Rancher Manager provides our customers with the ability to manage the operating system, the Kubernetes infrastructure, and the containerized application, all from one single dashboard. Talk a little bit about how customers use SUSE Edge. Again, SUSE Edge is a fully integrated stack, but it's also designed to be modular. And this is specifically there to enable the customer to deploy it as they need for their environment. Here are 4 different example configurations that are being deployed into production Edge environments today. The first example consists of just the SUSE Linux Enterprise Micro operating system and the Kubernetes layer. In this case, the Kubernetes that the customer selected was K3s. This small stack, optimized stack, is exactly what this particular customer was looking for to deploy into the trains, in this case, that they manufacture. The second example, this demonstrates a hybrid environment. This telco customer wanted to manage the operating system using SUSE Manager. Again, SUSE Manager is SUSE's Linux management tool. They also chose to manage the Kubernetes layer with Rancher Manager. This is truly a representation of a hybrid environment. The third example, this demonstrates SUSE's ability to be not only flexible, but offer a truly open source environment. Our SUSE Edge stack is tightly integrated with our SUSE Linux Enterprise Micro operating system, but it also supports other Linux operating systems. For this deployment, this large North American retail store had a preferred Linux distribution that was not SUSE's. SUSE Edge and the solution stack runs on other Linux operating system. This solution was deployed into roughly 2,300 locations across North America. And moving to the fourth example, this is the full SUSE Edge stack. In this example, again from another large North American retailer, they deployed the full SUSE Edge stack, including NuVector for zero trust security, Longhorn, SUSE Longhorn to provide block storage for their Kubernetes environment, as well as the rest of the Rancher, K3s, and SLE Micro stack, the entire stack. And they put this into their 1,300 plus locations across North America. SUSE Edge, as we've indicated, it's purpose-built, it's fully integrated, it's optimized for the edge. It's also modular, and it enables customers to deploy it as they need for their environment. SUSE Edge also enables customers to deploy data center grade security to every edge device wherever it is located. We provide the combination of an immutable or unmodifiable SUSE Linux Enterprise Micro operating system combined with zero trust container security provided by SUSE NuVector. Best in class edge security. The entire stack is orchestrated by SUSE Rancher Manager, and with the integrated Elemental plugin, it enables SUSE Edge customers to manage the full lifecycle of their Edge devices, from the applications to the Kubernetes layer to the operating system, all from a single pane of glass. You combine this full Edge stack with the functionality and the capabilities of SUSE's world-class support and our best-in-class consulting services. It enables SUSE Edge customers to minimize risks as they move compute into these Edge deployments. Because of the significant demand from SUSE Edge customers, SUSE Edge product releases will now, following our Edge 2.0 introduction release, come out 2 times a year. These 2 releases will be aligned with the Linux Foundation KubeCon event. A major or a .0 release will be available in the fall and announced at the KubeCon North American event, with a minor .1 release coming out in the spring, aligning with the KubeCon European event. All right, with this introduction and overview of what's available today with SUSE Edge, let's now transition to Reese Oxenham and let him talk to you a little bit more about the functionality coming with the next releases of SUSE Edge. Reese, over to you. Thank you.
Yeah, thanks a lot, Larry. So now that we've covered off where we've been up to this date, I'm going to give you a little bit of insight into where we're going and what our priorities are for the next release of our Edge stack. First of all, I want to cover off the concept of validated designs. As a software vendor, it's easy for us to think about solving problems by simply building products, and SUSE's product portfolio is extensive. But our customers often need more than just products to choose from. They need guidance. They need prescribed solution stacks that they can deploy within their organization. Systems architecture and figuring out all of the pieces is hard enough as it is. And the customers that we are interfacing with are wanting to really focus on their business differentiation and their competitive value without having to worry about how to assemble those underlying pieces themselves. They're looking to us to give them an opinionated, a prescribed, and finely integrated stack, one that takes into consideration lessons that we've learned from previous implementations and engagements with other customers, our best practices that we have taken from our engineering and from our quality assurance, and also take into consideration our recommended configurations to maximize that reliability and security. And this is what we're introducing as part of our validated design strategy. In the coming weeks and months, our SUSE Edge customers can look forward to us publishing a number of use case or market segment specific validated designs that will help and inform those customers on how they can build out our SUSE Edge solution. And it's really hoped that through the standardization of these validated designs that our customers will actually have a much richer user experience. They're going to be deploying well-known and recommended patterns of our software. Within a validated design, you'll find infrastructure and architecture guidelines, as well as the specific software versions, configuration recommendations, options for policy enforcement, and various other critical elements to really guide you through the deployment of a SUSE Edge solution. Validated designs are a critical part of our strategy moving forward. We really want to drive customer trust and confidence in our solutions. We are avoiding the need for our customers to deploy configurations that may just drastically vary between one another. And that ultimately makes it really difficult for us to support, engineer, provide lifecycle management for. And what we put out may not be a perfect match for every customer, as ultimately there's no kind of one size fits all configuration for every customer, every use case. that's out there. But we know that it can really form a solid baseline for approaching a deployment. And we can see that these will simply evolve over time as our technology portfolio expands. And some of the feedback that we take into consideration from our customers will be fundamental to us evolving these over time. That's not all. We're going even further with our validated designs and introducing something that we call stack validation. We are building a comprehensive integration and validation pipeline that rigorously tests these validated designs, and we do so in the real world. We're doing this because we really want to demonstrate the credibility and long-term reliability of these validated designs. And we intend to publish all of the results, all of the log files, where our customer can really dive into how we're testing and what the results were. And we're going to do it completely in the public. We want to provide our customers with a comprehensive dashboard showing those combinations, the software versions, and the results of all of the test runs. And we really want to make it available for everyone to use. So in terms of what we're covering as part of this stack validation process, we're building a mechanism that will take in a set of input parameters from the validated design. It will run a suite of tests and it will output all of those results, but also in combination with the results, it's also going to create a set of deployment artifacts that you could take and you could implement inside of Rancher and Fleet to reproduce the thoroughly tested stack exactly as we tested it, or at least maybe form the basis of a validated stack that's customized for your configuration. So we really want to make it really easy to take what we've tested in-house, put it through our stack validation, run through a whole bunch of tests that you can see on this slide, and actually start to build something from it, actually really use that as the basis for your deployment. So in terms of the tests, here's the high level list that we're implementing. And we know that these runs will likely take place on a daily basis. You can expect this data to be coming out all the time. So initial environmental and hardware configurations, where we're going to be using both bare metal and virtual machines to set up kind of real world, highly resilient hardware configurations as the base of the stack. That's kind of fundamental to all of this, the initial hardware configuration, the bootstrap process. Next is the end-to-end installation with specific component versions to ensure that we're able to deploy a set of components together, they come up as expected. Next up, and this is typically a bit of a sticky point, is the upgrade testing. Customers deploy one version, they want to know that they can move to another version later down the line. What we're going to be doing as part of our test is to simply run that testing procedure, deploy an older version, make sure that it can move to the latest version, so our customers are free to move between the released versions without running into bugs, regressions, or perhaps something that they don't want to be the first people to run into. Next is fault insertion. So we want to provide a kind of a randomized set of tests to ensure that the platform can be resilient. Disconnecting things, deleting services, or just introducing faults that we need to make sure that the platform can be resilient from and can respond to failures where we're really minimizing any downtime. High availability, so we abruptly remove nodes from the cluster and expect the resiliency of your platform to essentially maintain itself, and any disruption, again, is really minimized. Regression testing is also key to our strategy. We know that during the life cycle of a version, we shouldn't be introducing any breaking changes, but I don't want to say it's going to happen, but we might inadvertently introduce some changes where it breaks the API. We want to make sure that we're capturing that in our results before a customer will face it in their production environment. Next, performance testing. We want to kind of run a set of tests that are outputting some performance metrics, and we want to measure this over time. So providing our customers with a dashboard to see or kind of validate that over time the performance envelope isn't necessarily changing. And then finally, a number of day two operations. So node replacement, backup and restore. We really want to make sure that our customers are able to regularly use some of these functions and that they work as expected, and especially, they work as they're documented. So let's talk about some key roadmap items. On the left-hand side, you'll see that we have SUSE Edge 3.0, which we hope to release to coincide with KubeCon later this year, roughly the October timeframe. And then on the right-hand side, we've got Edge 3.1, which we hope to release then in the spring in the Northern Hemisphere. And that should coincide with KubeCon or Mobile World Congress next year. So I'm going to walk you through some of these features, and it's likely an area where many of you will likely have some questions. So first of all, bare metal provisioning in Edge 3.0. So we are graduating support for MetalCube-based bare metal provisioning. So for those of you that are unfamiliar with what MetalCube is, think of it as a Kubernetes project that enables the automated preparation and provisioning of bare metal hosts through an API. So we can say, we can provide it with the credentials, we can say power this machine on, attach this ISO, and so on and so forth. And we do that through a number of different APIs, predominantly the Redfish API. It gives us comprehensive hardware support, for a wide variety of platforms, be that from the likes of HPE, Dell, Lenovo, and so on and so forth. As part of this integration, we're also providing technology preview access to the cluster API or CAPI integration work. So this is really important from some of our customers in the telco space. We're also enabling support for elemental-based deployment as part of our MetalCube platform. So easing the onboarding and the automation of onboarding of real bare metal hosts that are out there in the world, should they have bare metal management capabilities like your ILO and your DRAC, but simply extending that to the elemental-based deployment structure that Larry mentioned previous in the presentation. In terms of security in Edge 3.0, well, of course, I'm sure you're here at SUSECon, you know about our NeuVector solution. We are creating an edge optimized deployment of NeuVector, really shrinking it down so that it can really work on the smallest types of hardware. In cluster provisioning and lifecycle management in SUSE Edge 3.0, well, we're starting off with that technology preview of the Rancher integrated cluster API. This will allow our customers to provision SleeMicro, RKE2, K3S with MetalCube. We're also introducing a couple of new components that we're building here in the SUSE Edge engineering team. And we're introducing them as technology preview in Edge 3.0 and hope to make them generally available in 3.1. The first one is what we're calling telco profiles. Telco profiles is really important. We know that our Edge stack is going to be really appropriate for customers in the telecommunications space. One of the things that we need to make sure that we provide is an API for defining specific underlying hardware characteristics, features, and tunables, as well as deploying certain operators or components within Kubernetes, and simply provide that API to our customers so they can really define it. It could be enabling node feature discovery. It could be enabling CPU isolation. It could be enabling SRIOV. There's a wide variety of things that we want to make sure that we can expose to our customers and have the platform take care of that configuration. Next is network customization. So this is the ability for when you think about rolling out a number of different machines out there into the wild, we need to sometimes make sure that we're able to force a specific networking configuration on a wide set of machines. That could be setting up bonding or LACP. It could be enabling VLANs on top of these machines. We want to provide a programmatic API for setting this up. Next is Edge Marketplace. So my team, we're building up a repository of Edge-specific components that we will support as per the SUSE Edge subscription that will enable customers to get access to certain Edge-specific components. We're integrating with Rancher. You'll absolutely be able to add our charts repo to your Rancher instance, and you'll have access to all of those components that are there. On workload support, so for those of you that are kind of unfamiliar with the way that our elemental stack works, we simply generate an ISO. You run that ISO, you attach that ISO to a target machine, and with Edge 3.0, you're going to be able to do that through MetalCubed. But imagine you've got an ISO, you ISO boot that machine, and the operating system comes up. Operating system SleeMicro gets deployed on that machine, and then Rancher takes over control through the elemental components that we've integrated into Rancher. Now, there's a couple of different things we're adding. First of all, the ability to declaratively customize the operating system. SLE Micro itself is an immutable OS. Making changes to that operating system is a little bit more, I won't say difficult or challenging, it's just a different approach to how you would do it from a more traditional operating system. We're providing support to drive further customization of that OS. The second thing we're doing is to implement a Rancher-hosted operating system ISO image. So today, or prior to some of the work we've been doing, a lot of that ISO generation was actually done on your local machine through a container. What we're doing today is we're actually having Rancher do the build and the hosting of that ISO image to really simplify the user experience. We're also adding some additional capabilities, so supporting WebAssembly workloads. We know that a lot of our customers are really interested in this. We're adding general availability for KubeVirt support with an integrated UI. A lot of customers talk about their use of Kubernetes for containerized workloads, but we know that many customers out there still have a lot of virtual machines out there, and they need a place to maintain these. And so we are adding support within our stack for KubeVirt, so customers can run virtual machines at the edge for a wide variety of use cases. We're also introducing a component called ACRI that's going to allow us to do management of IoT devices. I'm purposely going to leave this quite vague at this point because I've got a section that I'm going to come on to in a few minutes. And then the last one I'll mention is making generally available support of Metal LB or Metal Load Balancer. So we're going to be able to allow for organizations that are using bare metal clusters to be able to listen on specific IP addresses on the bare metal platform and have it load balance across a number of different pods in the platform without having to use an external or a cloud-based load balancer. In observability, metrics, and log management, well, we're really investing in the Opni project. So this is going to give us full stack observability and do a little bit of kind of AI ops at the edge, kind of predictive, understanding of what's going on for doing things like predictive maintenance and things like that of the platform. Get a lot of logging, metrics, and things like that outside of or with Opni. Lastly, on Edge 3.0 that I want to share with you today is those stack validation results. In a previous slide, I talked about the great work that we're doing in stack validation and shipping the results of all of the tests that we're doing. That's going to be going for its first public release in the SUSE Edge 3.0 timeframe. So Edge 3.1, I'm going to run through this list fairly quickly. It's generally kind of a high-level view of where we're thinking. This is sort of just under a year away at this point. So we're going to be on the bare metal side, we're going to be extending a lot of the work that we've been doing around bare metal management with Metal Cubed, and we're going to be building out a Rancher extension for doing some of that bare metal management. We're also going to be integrating with the Intel IAMT platform as well. We know that many of our customers are really interested in integrating with this. And as well, we're going to be expanding our certified hardware ecosystem. We know that many of the hardware OEM vendors out there have edge-specific hardware. We are, of course, working with all of those OEMs so that we can make sure that that hardware is widely tested, widely supported, widely certified. And we're also going a little bit further because we know that not all of these edge platforms are going to be x86. We know that many of our customers are going to want to use tiny ARM-based devices for the edge, especially when you move more towards the tiny edge type configurations. So we really want to make sure that we can really drive into that space, and not just Raspberry Pis, but also the likes of NVIDIA Jetsons, NXP or Verisite type devices. We want to maximize that compatibility, give our customers the broadest set of options out there. On the security side, measured boot support and announcement to the user. So, measured boot is essentially where it uses a hash into the TPM to identify whether certain things and firmware has changed. It can help you avoid rootkits and things like that. We want to make sure that this is in there, really heighten that security profile. Compliance with the FIDO device onboarding. So this is an initiative that Intel is certainly a huge proponent of. This is where we're doing kind of baked in firmware ownership, so you can essentially pre-bake configurations in at the factory, edge device gets shipped out, transfer of ownership happens, and it really ensures a little bit more of a secure device onboarding channel where you really know all of the devices that should be calling home. Cluster provisioning lifecycle management, so GA of the cluster API integration work we've been doing. GA of the network customization. We're going to be expanding and making the telco profiles GA as well. We're also probably going to rename the telco profiles cluster profiles. The work that we're doing in Edge 3.0 is predominantly kind of centered around the telco space, but we also know that from a more broader how do you define all of the features that you want to turn on and deploy on top of a cluster? We want to make that a little bit more kind of expanded, and so this is going to be something that we build into 3.1. We'll probably at that same time introduce a technology preview of a GUI that runs on top of it. What we'd love to do is take our validated designs, be able to select those as the basis, turn on and off certain features, make customizations, and it'll generate all of the templates that you need to issue the deployment, issue them through a GitOps type pipeline, and really drive some of that automation. Lastly, on cluster provisioning, branchless bootstrap of air-gapped edge clusters. So we know that not every customer that we work with has all of their devices connected to the internet or is within kind of network reach of the Rancher server. We are looking to provide an option for our customers that simply want to bootstrap either a single node or a cluster of devices in an air-gapped situation. Maybe pre-bake an ISO, it spins up, self-establishes itself, discovers its neighbors, establishes the cluster, spits out a kube config, and so that cluster essentially runs in somewhat isolation. There's lots of things we need to do on top of this. Things like patching and observability is going to be a little bit more difficult, but we're absolutely working on this. In terms of workload support, well, we're working with our friends at Buoyant on integrating Linkerd for service mesh capabilities. We think this is a fantastic solution. We want to bake this into our solution for service mesh capabilities and maybe extending it to communicate with edge devices that perhaps are a little bit too small to run Kubernetes, but we know we want to have them as part of our mesh. We're also working with our great friends at Synadia on integrating NATs. And there's a couple of different things we're doing here. First of all, I don't want to belittle it or anything, but more of a kind of generic message bus, but also as a potential replacement for etcd. And that is especially important when we look at configurations such as the 2-node mode HA. Now, don't think of 2-node mode as all of the benefits of 3-node or 5 or 7-node. It's a little bit more limited, but we want to start to introduce some predictive failover kind of scenarios and that really gives us the ability to do this. And so we're super excited to work with our friends at Synadia to do some of that. Last two I've got to cover on this. First of all, we're looking to introduce real-time kernel support on Arch64, ARM64 based platforms in SLE Micro. This is big because we know that many of our telecommunications customers are interested in sustainable telecommunications practices. ARM platforms are, of course, shown to be incredibly efficient, and many of our telecommunications customers, they need real-time support. This is not something we have today, but we're absolutely looking to bring this out in a future release. Then there's node remediation. Node remediation is essentially the ability to do some kind of automated failover of resources when we lose a node or it becomes unresponsive within the cluster. Typical Kubernetes behavior is we kind of assume that everything is cloud native and that applications will simply fail over or be a little bit more resilient. That's not always the case. Node remediation will give us the ability to do a little bit more automated failover or graceful failover. It's going to give us the ability to rapidly and without user intervention failover workloads, taking them off a failed node and putting them on a surviving node. Lastly, on the observability side, two major themes. Distributed stack validation tech preview. We know that our customers are likely going to want to leverage our stack validation process, but they're going to want to do it on premise, behind their own firewall, within their own hardware, their own applications, their own expectations. We want to make sure that we can provide this to our customers, and it also helps us with certification of hardware and various other things as well. And lastly, expanded scalability support. Our main problem that we're trying to solve here in the Edge BU is how do we implement or solve problems around scalability? And so we are really thoroughly looking through the stack as it is today and expanding on it so that we can make sure that we can maximize some of the scalability of our solution. So I'd like to introduce two key areas that we're introducing or certainly investing in terms of new markets for our Edge strategy. And I'll walk through these individually. The first is called Mission Critical Edge. Think highly available, purpose-built offerings targeting edge deployments that must maintain uptime, right? And we got applications in the kind of military, space, medical, financial world. They must be thoroughly and continuously validated and provide a long life cycle. Secondly is SUSE Edge Industrial IoT, where we're targeting industrial and manufacturing applications, things like remote monitoring and control, industrial automation, supply chain optimization, and predictive maintenance. I want to talk through these in a little bit more depth. So, mission critical edge. The concept of mission critical edge, or MCE as we typically call it internally, it stemmed from an engagement that we had with a customer where we really recognized that their risk profile and platform expectations went a little further beyond what we would typically have in terms of a customer engagement. The customer didn't need a product pitch. They didn't need us to solve their technical problems through features. And what we realized, given the kind of criticality of their industry, is that they were looking for a completely different engagement model from SUSE. They needed us to pivot and propose a model that wasn't centered around product. It was centered around how we engage with them, how we understand their needs, how we identify their requirements, how we retire risk, and how we can implement a platform that was centered around the 4 pillars that you can see on the slide here today. So firstly, mission critical resiliency. This is where we partner with prospective customers, conduct some deep dive workshops, really understand their expectations, their risk profile, their resiliency requirements, what their applications are, what integrations they may have. And so we can turn it into a tailored yet still aligning with our product strategy and some of our kind of original validated designs, build them a tech stack that really addresses some of those needs. Secondly, the concept of these continuously validated designs. So through the partnership with these MCE customers, the deliverable that we create and continually evolve is that continuously and rigorously tested validated design. We comprehensively document some of the integration points between SUSE components, maybe customer components, and thoroughly test them to ensure interoperability, expected behaviors, resiliency factors, and we also want to take into consideration customer-specific test cases. And like I mentioned in the previous slide about the kind of distributed nature of this, it's their hardware, it's their applications, it's their expectations. These are things that are very difficult for us to do internally. Thirdly, zero trust security and accelerated compliance. SUSE is absolutely no stranger to working in regulated industries. We've worked extensively within the US IC and DoD organizations, and our security strategy is kind of built to align with that experience. We've got a compliance framework, a secure supply chain, security policy enforcement throughout the entire design, and we're really able to demonstrate that comprehensive security posture across the entire MCE engagement. Finally, we've got long-term support. We know that many of our customers in the MCE kind of ecosystem will be implementing solutions that have to be out there in the wild for many years. It's often not feasible to regularly lifecycle, or at least not do any more than basic security patching if it's the most critical of patches. You can't typically do this within the typical life cycle of the platform. So through that extensive work, partnership in terms of validating and design and implementing a lifecycle management process, and perhaps attaching dedicated engineering resources, we're able to provide or negotiate support and tighter SLAs for our MCE customers. So next I want to have a brief mention of our industrial IoT strategy. And we know that in advanced manufacturing, they're really going through this kind of another cycle of fundamental change. This is often referred to as Industry 4.0 or smart factories. In an attempt to drive up productivity, reduce failures, improve safety, optimize efficiencies, industrial manufacturers are looking to revolutionize their manufacturing process through edge computing, containerization, Kubernetes, and so on. What we're starting to see is that devices used for manufacturing are becoming smarter, more automated and autonomous, and more capable. We're giving them more local processing power, the ability to utilize a wide variety of peripherals, be that cameras or sensors or anything like that, to do data analysis there and then, without relying on centralized infrastructure, and using AI for analysis of analysis and detection of issues, abnormalities, which ultimately leads to that increased productivity, a reduced failure amount, but also an increase in safety, both from the devices and also for humans alike. The problem that we see is that manufacturers really need to modernize thousands of machines and even more thousands of IoT devices. You think about a manufacturing organization that has thousands of locations. You think of all the machines that reside inside of those locations. They're trying to modernize all of that. Is a very difficult task. And what SUSE has been doing so far, our strategy has really been around helping with many of the operational challenges when you get to this sort of scale. How do you do the onboarding of those devices? How do you manage them? How do you patch them? And how do you secure that infrastructure? And we have a quote from our general manager here. We really want to be one of the first to deliver that kind of fully integrated cloud native solution, especially as we look into the advanced manufacturing, industrial IoT space. So in SUSE Edge 3.0, we are going further than just thinking about the fundamentals of how you operationalize this type of infrastructure. We are productizing and introducing Project Acri to our portfolio to help with some of the IoT device discovery, enumeration, and consumption within Kubernetes, helping organizations in this space more quickly standardize on edge computing, Kubernetes containerization, and really allowing them to focus on the core functions of their business. If you imagine all of the various different legacy systems that are out there, and the silos in terms of hardware and software and the life cycles that are there, driving towards edge computing, Kubernetes containerization, the security factor, and the kind of standardization in terms of the operations is huge for many of these organizations. We're really trying to make sure that that we're providing that. But Project Acri is really thinking about how these devices that are really at the edge in some of these factories can be consumed inside of Kubernetes. So out of the box, Acri has a broad set of supported protocols and interfaces for that device discovery, be that kind of more traditional plug in a USB host device, but there's also industry-specific protocols like Zigbee or Modbus. And there's even support for your specific protocol, as it says, but you think of this as more custom. Build it, and it can be consumed and utilized inside of Kubernetes. Bring your own. So a wide variety of legacy devices. These could be over RS-232 or some other kind of more legacy interface. So to wrap things up, this is a high-level view of the stack that we are building for the edge. We know that there's no one-size-fits-all configuration here, and that customers will want to customize, swap pieces out, or embed existing investments into our solution. And our solution is customizable, right? We're utilizing open source, open standards, open APIs here. It should be possible to leverage those. We want to make sure that our customers can leverage some of those existing investments, whilst also having the freedom to utilize and consume a wide variety of components that are out there in the open source ecosystem. We just know that we are building the world's most comprehensive open source edge stack, and the capabilities are seriously growing. We know that it's going to be appropriate for use in a wide variety of use cases. I couldn't be more excited about what we're building here in the Edge business unit. We certainly look forward to sharing our upcoming Edge 3.0 with you later this year. So that's a wrap. Thank you so much for attending this session. Larry and I hope that you will enjoy the rest of SUSECon 2023.